Hey everybody, so in this video we're going to start section 4.2, which is titled the vertex. Okay, we're really going to talk about different problem solving techniques that involve the vertex. Okay, so before we even start this, let me give you guys something that's going to help us with these more applied problems. Okay, all right, so I want you to remember, okay, that we were calling the vertex H and K. Okay? All right. So if we have a quadratic formula in standard form, or a quadratic equation in standard form, okay, okay, we can find the x-coordinate of the vertex, which we were calling H, by doing minus b over 2a. Okay, now we didn't talk about this in the previous section because we don't really need this for graphing. This isn't really a huge help when you're graphing, okay, because you would still need that a value, okay, in order to make a good graph, okay, but it is going to help us with some applications. Okay, so let's look at this first example. Okay, so it says, try to get the video to focus. Okay, so we have x squared plus 6x plus 5, and it says for what value of x is y smallest. Okay, so if we're thinking about this parabola, okay, this is going to be a parabola that opens up, and we know this, okay, because the leading coefficient in front of x squared is positive. Okay, so if we're looking for the smallest value of y, we can say that it should be at this point here. Okay, so we can see that this is at the vertex. Okay, so if we're looking for this, this is going to be the x-coordinate of the vertex. Okay, and we're going to use the minus b over 2a from the previous page that we talked about. Okay, so for this it's going to be minus 6 over 2 times 1. Okay, so this would be negative 3. Okay, so this is the x-coordinate of the vertex. Then it says, what is that smallest value of y? Okay, so that's going to be the y-coordinate of the vertex. And we can find this by just plugging in our given x-coordinate. Okay, so we're plugging into our original equation our x-coordinate that we found in part A. Okay. Okay, so this should give me y equals negative 4. Okay, now again, this is the vertex. The vertex would be negative 3, negative 4. Okay, but this is also telling us that the smallest value of y is going to be negative 4, and that's going to occur at x equals negative 3. Okay. All right, so this second question is very similar. Okay, we're given this equation. Okay, then it says, for what value of x is y smallest, and then what is that smallest value of y? Okay, so again, we're looking at a parabola that opens upwards. Okay, so the smallest value of y is going to be at the bottom, which is the vertex. Okay, so we're going to use x equals minus b over 2a. Okay, so minus 4 over 2 times 1, which is negative 2. Okay, and then we're going to plug in this x value to find its corresponding y value. Okay, so we'll get 4 minus 8 plus 2. Okay, so this is going to be negative 2. Okay. All right, so our smallest value of y is -2, and that's occurring at the x value -2. Okay, so let's look at another example. This says, for what value of x is y largest? Okay, in the previous examples we were looking for smallest y, and now we're looking for largest y. Okay, so we're going to look at this. We know this is a parabola shape, and we have this minus here, so we know it's going to open down. Okay, so that means that the largest point is going to be at the top here, which is still the vertex. Okay, so the vertex is a maximum if it's opening down and a minimum if it's opening up. Okay, so we're going to use that same formula to look for the vertex of this. Okay, so we would have minus b over 2a. Okay, so I'll get 4 over -4, which is -1. Okay, so this largest value is occurring at x equals 1, at x equals -1, and then we can plug in to find that actual value. Okay. So -1 squared is 1, so this is going to be -2 plus 4 plus 3. Okay, so this should be 5. Okay, so the largest value of y is 5, and it's occurring at the x value -1. Okay, and now we're asking a very similar question here. For what value of x is y largest? We can see we have this negative sign out front again, which means we're facing down. Okay, so this maximum point, right, where y is largest, is the vertex. Okay, so we're going to look for the vertex. Okay, so we'll have -12 over 2 times -3. Okay, so -12 over -6 is 2. Okay. So we're going to plug that in to find our largest value of y. Okay, so 4 times 3 is -12, plus 24 minus 3. Okay, so I get 9. Okay. So let's see how we're going to use this in more application type settings. Okay, so we have a word problem. A ball is thrown off of a roof. Its height after t seconds is given by this function. Okay, now it says, when will the ball reach its maximum height? Okay, so again we have a parabola, and because of this negative sign we know that it's facing down. Okay, so the ball's maximum height is going to be at the vertex. Okay. Okay, and we're going to find this vertex using the formula minus b over 2a. Okay, so we'll have minus b over 2a. Okay, so this is going to be -8 over -32, which is 1/4. Okay. Don't forget that because this is a word problem, you should have a sentence answer. Okay, so when will the ball reach its maximum height? After 1/4 second. Okay. Then part B says, what is the ball's maximum height? Okay, so now we're going to plug in our t value to our function, okay, and find out its height. Okay, so we'll have h of 1/4, and remember we're using our function notation here, so we'll get -16 times 1/4 squared plus 8 times 1/4 plus 30. Okay. Okay, So 1/4 squared is 16, or I mean 1/16. Okay. Okay, so negative 16 times 1/16 is -1. Okay, 1/4 of 8 is 2. Okay, so we'll have that the height is 31. Okay, so what was the ball's maximum height? Maximum height was 31 feet. Okay. All right. So that's it for part 1 of this video, and I will see you guys soon.